Hello, my dear students. This is your physics teacher Ashish Sharma, and I welcome you all after summer break to our online classes of Pathania Public School. I hope you enjoyed your summer break very well. You did very good in your UT, I checked, and I'm sure you are going to rock your performance this time. With the effort we put together, we are going to make your physics better than any batch ever. So, with all my wishes, let us start our today's lecture. Dear students, we have been discussing the chapter gravitation and first half was done, and today I will give you a brief recap before we'll start so that we can pick up from the point where we left the discussion. So, we were discussing about thrust and pressure. That was the last lecture. And what is thrust and what is pressure? Uh, Let us revise. So, what is thrust? Thrust is the force acting perpendicular to the surface of an object, and that is known as thrust. Unit of thrust is the same as that of force, and that is Newton. So, like, what is thrust? Like, suppose you are having this surface of any object, you may have force in any direction. Like, this is a force F1 which is applied, this is a force F2 which is applied on the surface. So we can observe that we are having these force which are inclined at some angle theta, and that theta is not 90 degree. Now let us consider a force which is perpendicular to the surface making angle 90 degree. So you can see when force is making angle 90 degree with the surface, then that particular force is known as thrust. So thrust is nothing but the same force with the angle which is 90 degree to the surface. Why we are studying about this 90 degree concept? Let me tell you. We will study about fluids in a container. जब भी हम किसी liquid को, whenever we are taking a fluid in a container, whenever we are taking a liquid in a container, then this liquid applies a force which is perpendicular to the surface of container. So you can see there is always perpendicular force to the surface of container. So this force which is applied by the fluids on the walls of container is also known as thrust. And as we have studied, units of thrust and force are same, that is Newton. Second term in discussion is pressure. First is thrust, second is pressure. So pressure is defined as force per unit area or thrust per unit area, and it is known as pressure. So pressure is defined as thrust per unit area, or we can say perpendicular force as we discussed, divide by area. तो परपेंडिकुलर फोर्स को जब हम एरिया से डिवाइड करते हैं तो हमें क्या मिल जाता है? प्रेशर मिल जाता है. अब बच्चे आपको पता है कि जो फोर्स है उसकी यूनिट क्या है? उसकी यूनिट है न्यूटन, और एरिया की क्या यूनिट है? मीटर स्क्वायर. तो जब हम न्यूटन को, फोर्स की यूनिट को एरिया की यूनिट से डिवाइड करेंगे तो हमें किसकी यूनिट मिल जाएगी? प्रेशर की. सो यूनिट ऑफ प्रेशर इज़ न्यूटन पर मीटर स्क्वायर. व्हेन वी डिवाइड द यूनिट ऑफ फोर्स by unit of area, we get the unit of pressure. And let me tell you one more thing, that this 1 newton per meter square pressure is also known as 1 pascal. You know that pascal is the name of physicist after which we named the unit of pressure Pascal. Pascal did great work in the field of pressure, and he also gave us a law in hydrodynamics which is known as Pascal's law. For now, we are not going to discuss Pascal law, but we will understand the concept of pressure. So here, with the help of an example, we will try to understand how, with the same given block of same mass, how can we achieve different pressures. हम एक ही बॉक्स से जिसका मास सेम है, हम दो अलग अलग प्रेशर की वैल्यूज़ कैसे अचीव कर सकते हैं. तो आपके सामने ये एक बॉक्स है. यू आर हैविंग अ बॉक्स हुज डायमेंशंस आर 40 centimeter, 10 centimeter and 20 centimeter. So this shape is cuboid. So in first shape, I placed it like this, so that the face 10 by 20 centimeter side is towards ground. So I can show you by dotted lines the internal side of this cube. So, and by red color I'll show you. So this much is the area which is touching the ground, and we can calculate this area very easily. This area is 10 centimeter into 20 centimeter. If I will write them in meter, 0.1 meter and 0.2 meter, that is 0.02 meter square. And similarly, the mass of the box is given 5 kg, and we all know that W is equal to mg. Taking g approximately 10 kilometers, the weight of the box will become 50 newton. So this 50 newton is actually the force or the weight which is downward. And we just studied that pressure is defined as force upon area. सो अगर हम फोर्स से एरिया को डिवाइड करेंगे तो आप एक चीज़ का ध्यान रखो यहाँ पे कि हम एसआई यूनिट में काम कर रहे हैं, इसलिए हमने वेट को न्यूटन में लिया और एरिया को मीटर स्क्वायर में लिया. आपको कन्वर्ट करना आता है मीटर सेंटीमीटर से मीटर में. वी नो दैट 1 मीटर इज इक्वल टू 100 centimeter. So if we are having any measurement in centimeters, like we had 10 centimeter, for converting into meters we just simply divide it by 100 and we'll get 0.1 meter. Similarly, the other face was of 20 centimeter length, and divided by 100 will get 0.2 meter. So these two lengths, when I will multiply them together in meters, 10 and 20, I will get the area in meter square. That area is here in meter square. So I get the value of pressure dividing 50 by 0.02. I'll get 2500 Newton per meter square. So this is the pressure which I am getting when my box is placed like this. Now if I change the orientation and the larger area side is now towards the ground, I can calculate the area again by simple method of area, calculating area from rectangle length into breadth. So length is 40 centimeter, and we know that 40 centimeter in meter is going to be 0.4 meter dividing by 100, and similarly 20 centimeter is going to be 0.2 meter. As the box is same, mass of the box is going to be same, so weight of the box or the force which is downward is going to be same, 50 Newton, taking G approximately 10. So for second case, when we will calculate the pressure, the force downward is same and the area is 0.4 into 0.2 as I discussed with you. So 50 Newton divided by 0.08 meter square. This time you get 625. Look how this value is different so much. Earlier that value was 2500 Newton per meter square, and now this value is 625 Newton per meter square. So clearly, it is very clear from this discussion that from the same box we achieved two different pressures. When area was small, then we get the large pressure, because for calculating pressure we use the formula weight or force divided by area. So smaller the area, if you divide by a number which becomes smaller and smaller, your quotient or pressure will become greater and greater. So that is the first case. Your area is small, that is 0.02, so you get the pressure 2500 Newton. This area was small, 0.02 meters square, and you get the pressure of 2500 Pascal or Newton per meter square. In the second case, we observed our weight or force of the box is same, as the same box is being used, but the larger area side is used towards bottom. 0.08 is much larger than 0.02. So when in formula, if our area is increased, we have observed that pressure has decreased. So the value of pressure becomes from 2500 to only 625 Pascal और न्यूटन पर मीटर स्क्वायर. ठीक है, तो आप ये देखो कि किस तरीके से सेम बॉक्स होते हुए सेम मास. नाउ यू कैन अंडरस्टैंड इट वेरी वेल कि हाउ अ nail can be put into a wooden box if it is if the pointed side is facing the wood. If you will put the flat side of a nail on a wooden box and you will hit from the hammer on the other side, the nail would not go into the wood that easily. Now you understand the concept of pressure. Let me give you a few more examples so that it will solidify your concept. Look here, like you are having a thumb pin. The thumb pin is in this shape, which is sharper from one side and larger area is on this side. So we apply force by thumb on the broader side so that this thumb pin generates a large pressure where it is touching the drawing board, because it is having very small area. So by decreasing the area we are getting very high pressure. Is it required to increase the pressure all the time? No. There are some applications where we require to decrease the area. Like you carry your shoulder bags, and if you are having so many notebooks and books in them, they become so much heavy, and you don't need much pressure on your shoulders. Otherwise, you will get marks of the strip of the bag on your shoulders. So for providing ease to you, you have seen that the straps of the bag are broadened. Their area is increased. The straps of the bag, their area has been increased. So greater the area, lesser the pressure on your shoulders. If you will use the narrow strips instead of broader, you will see there is lesser area available with the same force and you will be having large pressure. But if your area is large, you will be having lesser pressure comparing to thinner strips if you will use on your shoulders. So let me ask you a question. I will answer you in next lecture. When we are walking on sand, so our feet should not go into the sand. So for doing that, whether we need larger area or smaller area, I will discuss this thing with you in live class. And if you go through this video before the live class, then we can discuss the same. Okay, thank you, take care.